This is Mr. Martin. This video is for Pre-Calc Honors. We are in Chapter 4 and we're looking at graphing secant and cosecant. So for this example, we're going to look at graphing two full periods of y equals 3 cosecant 4x. So when I do secant or cosecant graphing problem, what I like to do is I like to just think about graphing its inverse function. So actually it's reciprocal function, but so I'm going to look at graphing y is equal to 3 sine 4x. So we're going to go through the whole problem thinking about 3 sine 4x, and then at the very end when we do the graph, you'll see I'll make some changes so that it's actually a cosecant graph and not a sine graph. So we've got a is equal to 3, b is equal to 4, there's no c value, and there's no d value. So we have no phase shift and no vertical shift. So then we'll figure out the amplitude. Amplitude is the absolute value of a, so that's 3. We'll figure out the period. That's going to be 2 pi over b, so 2 pi over 4, which is pi over 2. And then our phase shift is c over b. We said that's 0 already. And our vertical shift is also going to be 0. And then the last thing that we want is the distance between key points. That's going to help us find some good values to graph, and then also how to label our graph. So that's going to be the period divided by 4, so pi over 2 divided by 4, so that's pi over 8. Alright, so then, since there's no phase shift, I'm going to start my table at 0, and then I'm going to go up by pi over 8. So 0, and then pi over 8, and then 2 pi over 8, which is pi over 4, and 3 pi over 8, and then 4 pi over 8, which is pi over 2. And again, I'm going to calculate these values like I was doing a sine problem. So substitute in 0, sine of 0 is 0, 3 times 0 is 0. Substitute pi over 8, so that's going to be pi over 2. Sine of pi over 2 is 1, times 3 is 3. And then substitute pi over 4, so that's going to be pi, that'll be 0 again. 3 pi over 8, that's going to give me 12 pi over 8, which is going to reduce to 3 pi over 2. So that's sine of 3 pi over 2 is negative 1, times 3 is negative 3. And then pi over 2, that's going to give me 2 pi, which is going to be 0 again. So here's 5 key points. So I'm going to start graphing these. I'm going to use my distance between key points to label my x-axis. So I've got pi over 8, pi over 4, 3 pi over 8, 4 pi over 8, which is pi over 2, 5 pi over 8, 6 pi over 8, which is 3 pi over 4, 7 pi over 8, and then 8 pi over 8 is pi. That should give us enough for 2 full periods. And then we'll just mark this as 3, and we'll mark this as negative 3. And let's go ahead and graph these points. So I have 0, 0, pi over 8, 3, pi over 4, 0, 3 pi over 8, negative 3, and pi over 2, 0 again. Now, here's where things are going to change a little bit. If this was a sine curve, I would just draw a nice smooth curve through this, but we're really graphing the cosecant. So I'm just going to use this as a helper. So now I'm just going to put a dashed line between these points, sort of like an asymptote, in that we don't draw it solid because it's actually not part of the graph. And then I'm going to continue on with one more period, just keep following my pattern. So I'm going to have 5 pi over 8, 3, 3 pi over 4, 0, 7 pi over 8, negative 3, and pi 0, and then again dashed line, connecting my points. And this is 2 full periods of the sine curve. Now, we have our maximum values at 3, we have our minimum values at negative 3, then we have these 3 points in the middle. These key points in the middle are where the sine is 0. So that means that the cosecant is going to be the reciprocal of that. The reciprocal of 0 is undefined. So at each of these spots in the middle, the cosecant is going to be undefined, and we're going to have asymptotes there. So I'm going to put in these asymptotes. So I have one there, one at pi over 2, another one at 3 pi over 4, and one more at pi. So we actually haven't graphed the cosecant graph yet, but I'm going to do it right now. So now at each maximum and minimum point, we're going to take the part of the curve from the sine and we're going to flip it the other way, except now instead of going through the x-axis, we're going to approach our asymptotes. So we approach the asymptote there, y-axis is an asymptote, then we're going to flip it here, approach our asymptotes on each side, and then same thing over here, and one more over here. So the blue portion in my curve is the actual graph of y equals 3 cosecant 4x. The rest is just kind of helping us. Alright, so that's y equals 3 cosecant 4x. If you have any questions, make sure you reach out, and we'll see you next time.